These are some examples of what we call complex fractions. Now, complex fractions get their name because we have a fraction bar where in the numerator and the denominator we could have other fractions, adding, subtracting, other operations that need to be happening with fractions. So you have a fraction divided by a fraction, or in this case you have a whole number minus a fraction divided by another whole number plus a fraction. And so we say this is the difference between two numbers divided by the sum between two numbers. Or we could have something that looks kind of crazy like this, where we have the difference between two fractions divided by the sum of two other fractions, where we have unlike denominators. So we're going to go through these examples so that way you can see a few ways of how you're going to simplify complex fractions. And let's start with the letter A. What you want to notice is you want to notice that this is the fraction in the numerator, and this is the fraction in the denominator of a larger fraction. So what we're going to do is, because this fraction is already what we considered to be simplified, what I mean is the numerator is one fraction divided by the denominator as one fraction. We can turn this middle division bar into the division symbol and rewrite this fraction horizontally. For example, t plus 4 divided by 3t, and that larger division bar can be our division symbol, and then the denominator, 2t plus 1 over 9t. So what we've done is we've taken a division problem that's written vertically and rewritten it horizontally. And the purpose of that is that now we can multiply by the reciprocal. So now I'm going to multiply by that right-hand fraction. So I'm going to leave my t plus 4 over 3t fraction alone and multiply by the reciprocal of the right-hand fraction. Now I have a multiplication problem. So I need to be able to make sure that anytime I have two terms in the numerator or the denominator, that they are completely factored. And these are. So these are what we consider binomial factors, where they have nothing in common, but those terms are hooked together. I can, however, simplify down a t from both the numerator and the denominator, and a factor of 3 from both the numerator and the denominator. And when I write what I have left, I have a 3 in the numerator times the t plus 4. And in the denominator, I have 2t plus 1. And so this is my simplified fraction. I'm not allowed to simplify this any further, but I do need to include my restriction that t is not equal to negative 1/2. So we still have to look at when is the denominator going to be equal to 0, so that way we can simplify our fraction and know the restriction. So that's the basic process when we are already written as a simplified fraction divided by another simplified fraction. So let's look at the process when it obviously gets more complicated. So again, recognize that that is the expression in the numerator, and this is the expression in the denominator. Now what we need to do is we need to rewrite these as one fraction in the numerator and one fraction in the denominator. So what I'd like to do is I'd like to look at this numerator, and I want to be able to subtract the 5 minus 2y, which means I need a common denominator. So what I'm going to do is I'm going to rewrite my 5 minus 2y, and I'm going to get a common denominator by multiplying both top and bottom by y. So now the numerator, if I rewrite this in descending order, is the expression 5y minus 2 over y. So this is my new numerator. I have simplified the two terms that were in the numerator to look like one fraction instead of two. Right? That is still being divided by these two terms. So again, over off to the side, I want to be able to add these. And again, I need a common denominator. So I'm going to multiply top and bottom by y. And when I rewrite this fraction, I end up with 4y plus 1, also divided by y. And this is my new, we call our simplified denominator. And so now that I have created a simplified complex fraction, this looks very similar to the first one. And so this middle fraction bar again is my division symbol. And I'm going to write this horizontally. That way I can see how I'm going to flip this. And when I leave my first fraction alone, and I want to be able to change this fraction, I'm going to multiply by its reciprocal. And you can see that the only the only factor I can cancel is actually the y's. Because this 5y minus 2 has nothing in common to factor out, and neither does this 4y plus 1. So when I simplify this down, I get 5y minus 2 over 4y plus 1. And again, there is a value when y cannot equal negative 1/4 as my restriction. So you can see that the process, when we have these complex fractions, it does take a little bit longer when you have more operations to do to simplify, but our goal is to always simplify to get a complex fraction like this, or like this, where we have one fraction in the numerator and one fraction in the denominator. So let's look at letter C, because that's going to be the most complicated, but the process is very similar. And there are alternative ways to being able to do these problems. There are two methods to being able to simplify complex fractions, and I will show you a shortcut later, but right now let's just focus on this process. So again, let's look at this numerator right here and this denominator right here. So in the numerator, and if I just focus on just that top part, I'm going to need to have a y and a y minus 1 to create my common denominator. And so what I'm going to do is I'm going to multiply right up here each fraction by what's missing. And then this numerator, I'm going to have to multiply out some things. Right. So I'm going to do that. I'm going to start writing what's going on with this numerator. Now I know that I'm going to have a y and a y minus 1 as the denominator of this top fraction. Right. But I need to multiply out this binomial times a binomial, which is going to give me a y squared plus a 2y minus 3. And again, you can go off to the side and do an area box or something that allows you to multiply this 2 by 2 out. Minus 4y. And so I'm going to put my simplified fraction over here off to the side because that's not completely simplified. That's the same as y squared minus 2y minus 3 over that y times y minus 1. And again, that's all my simplified numerator. I'm working with just the numerator. Okay. So now what I'm going to do is I'm going to do the same technique and focus just on the denominator. So in this denominator, again, I'm going to need to have a y and a y minus 1. So both of these fractions are going to need to be multiplied by the factor that's missing. And again, I'm going to do my work. I get a y squared plus y minus 1 And that's over that denominator. And what I can see is that I actually have already simplified that one down. Y squared plus y minus 1 over that denominator. And so hopefully you're going to start seeing something that's going to start happening here. If you notice, in this second fraction, I had a denominator of y and a denominator of y. And when I multiplied by the reciprocals, the denominators canceled, and I was left with just the numerator over the numerator. And that's a rule of fractions, that when I have a complex fraction where the denominators are both the same, because of how they multiply by the reciprocals, the denominators eventually end up canceling out. So let's look at how that's going to work over here. So I have a y squared minus 2y minus 3. Right? And one way we can start shortcutting this is, instead of writing divided by this fraction, we can write it as times the reciprocal of the denominator. And that's what we've been doing. Instead of writing the first fraction divided by the denominator and then multiplying by the reciprocal, I'm going to shortcut that a bit and just, as my first step of rewriting, multiply by the reciprocal of the denominator. And you can see that these factors all cancel out. And so what we're left with at the moment is this trinomial on the top and a trinomial on the bottom. Now we always have to double check to see if these are factorable. And this denominator is not factorable. All right, this denominator is prime, because there's no way that I can multiply two numbers together to get -1 but only add up to be +1. That's not going to work out for us. So I do know actually that this numerator is factorable, but I'm not going to worry about factoring it because I can't do anything with the denominator. And so this is going to end up being our final answer. Okay. Now there are values that are restrictions to this, but they are going to be created by radicals or complex fractions. And so I'm not going to worry about the restriction on something that I can't factor. Again, you can try to do the quadratic formula, but if I get a negative under the square root, if I get a complex fraction with an I, I'm not going to worry about that. All right? And so one way that we can check that is with that discriminant. All right? And so back in some quadratic notes a while back, if we check this discriminant and I get something that is negative, then I'm not going to worry about a restriction. All right? And so for this case, I end up with 1 minus 4 times 1 minus 1, which is 5. So this does have radicals in it. I wonder what that would look like. So there are some restrictions to this, right? But I'm going to wait on those restrictions right now. They're going to get a little bit complicated, and so if I can't find something, you know, a nice little rational restriction, I can see that this is going to have some sort of restriction, but it's going to be radical. So I'm going to have to use the quadratic formula to find a restriction. All right. And now, since we usually do not simplify complex fractions with radicals, such as 1 plus root 5, I'm actually not going to worry about this today. I'm going to leave my answer looking like this. So if I can't factor this in any way, if this is not factorable, don't worry about restrictions. Right? However, if this is factorable, you are going to need to worry about restrictions. All right? So not factorable. With rational roots.